So what we talked about yesterday was inverse and direct variation, and we talked about kind of being able to determine if an equation was inverse or direct. And then we also went over kind of talking about if we were given a set of numbers, a set of data, if it's direct or inverse variation, being able to test it. And now what we're going to do in the last part of this lesson is kind of finding a number. Now here it tells us x and y vary inversely. And y is equal to 4 when x is equal to 3. Write an equation that relates x and y. Then find y when x is equal to negative 2. So if they vary inversely, what would that be? So y would equal what? Because varies inversely is because y equals a over x. That's just what it, kind of our general equation for if it varies inversely. Now, we're kind of given some information. Y is equal to 4 when x is equal to 3. Yes? So we could plug that in using this equation. And if I plug it in, well, I would say what? Why is this helpful? Well, I can find the value of a, yes? So what would I need to do to find the value of a? I would multiply both sides, but not by 4. Because if I multiply both sides by 3, this 3 and this 3 here will cancel out, giving me a by itself, yes? 3 times 4 is? So the value of a is 12. So really in this original equation, for varies inversely, y is equal to, well, 12 over x. And this gives us an equation that will give us any value of x or y that we would want to know for this comparison here. I'm going to erase this here. So now the last part was to find y when x is equal to negative 2. Well, how can I do that? Into our equation here. Because we could say y is equal to 12 over, well, 12 divided by negative 2 is? All right. All right, guys, any other questions on this one here? Okay, let's look at the next one. All right, guys, so we're going to look at a few more of these here, and that's actually going to be it with this lesson here. So what we do for this one here is actually very similar to what we did with the first one. Now, the variables x and y vary inversely, and y equals 8 when x is equal to 4. Well, again, so we're still using y is equal to a over x. And what's nice about this here is if we can find the value of a, then we could be able to solve for the value of y when x is equal to negative 16. Well, we can do that by first, well, using the fact that y is equal to 8 when x is equal to 4. So we can say 8 is equal to a over 4. And to solve this here, we would multiply both sides by 4, because the 4 and 4 would cancel, telling us that a is equal to what? 32. So we found this constant value, which we can plug back into our equation, which would be y is equal to 32 over x. Now, we just need to find the value of y when x is So y would equal 32 over negative 16. And 32 divided by negative 16, well, positive divided by a negative would be a negative. And it would be 2. 36 divided by 16 would be 2. Huh? I mean, there's always... I mean, we can find... All right. Let's do one more of these at least, because I think... Because once we get the hang of kind of the overall process and kind of what we're doing, these start making a little bit more sense. Now, x and y, again, are varying inversely, so our equation for if they vary inversely is y is equal to a over x. So really, I need to find the value of a, and once I find the value of a, then I can find the value of y that I'm looking for. Well, we can plug this in, so we would have what? 5 is equal to a over 4. And then we would multiply both sides by 4, because 4 and 4 would cancel out, telling us that a is equal to 20. We can plug that in to get our equation. And they want us to find the value of y when x is equal to 2. So y would equal 20 divided by 2. So the value of y would be? And that's it there. Any questions on any of this here? We feel comfortable with this here? Yes? Okay.